Checking for overlapping schedules looks like a tedious comparison problem, but there is a sorting trick that turns a quadratic nightmare into a linear scan. The goal is simple. Given an array of meeting time intervals, determine if a person can attend all of them. Essentially, we need to check if any two meetings overlap. For example, if we have one meeting from 0 to 30, another from 5 to 10, and a third from 15 to 20, the answer is false. Why? Because that first long meeting completely swallows the other two, making it impossible to attend everything. We just need to return a Boolean indicating if the schedule is conflict-free. The most intuitive way to solve this is to compare every single meeting with every other meeting using nested loops. We would pick one interval and check it against all remaining intervals to see if their start and end times overlap. While this works, it's incredibly inefficient with a time complexity of O of n squared. As your calendar grows, the number of comparisons explodes, making this approach far too slow for production-scale data. The key insight is that if the meetings are sorted by their start times, we only ever need to compare a meeting with the one immediately preceding it. First, we sort the entire array based on the start time of each interval. Then, we iterate through the sorted list starting from the second meeting. For each meeting, we check if its start time is earlier than the end time of the previous meeting. If it is, we've found an overlap and can immediately return false. If we make it through the whole list without a conflict, we return true. Let's trace our example. Our intervals are 0 to 30, 5 to 10, and 15 to 20. After sorting by start times, the order remains the same. We start at the second meeting, 5 to 10. We compare its start time, 5, to the previous meeting's end time, 30. Since 5 is less than 30, we have an overlap right away. The function immediately returns false, and we're done without even needing to check the third meeting. You'll recognize this pattern whenever you see intervals or time ranges. If the problem asks about overlaps or merging, your first instinct should almost always be to sort by the start time. The time complexity is O of n log n due to the sorting step. The space complexity is O of 1 since we are sorting the input in place. Now try the merge intervals problem. It uses this exact same sorting pattern. Subscribe for more DSA deep dives.